Hi, my name's Leah and I'm a biology major at VSU, and today I'm going to be demonstrating how a homemade lava lamp works. So the materials that you're going to need are a clear bottle to put all your stuff in, some vegetable oil, some water, some food coloring, and an Alka-Seltzer tablet. I got the Walgreens brand, but anything similar to Alka-Seltzer. So first, what we're going to do is we're going to fill up the water bottle with vegetable oil about 2/3 of the way. So we're going to go ahead and do that. And I got a new bottle just to do this. So we're going to go ahead and pour that in. Try to limit the mess. Woo-hoo. Alright, mine doesn't go so far up, but it's good enough. So next what we're going to do is pour in some water on top of the oil, and the water is denser than the oil, so it's going to sink to the bottom. Okay, I'm going to leave some space at the top. So next we're going to take our food coloring. You can use any kind of food coloring, you just got to be water based. You're going to put a little bit of that in there. And I'm going to just swing that around a little bit, try to get it to settle some. Okay. And then you're going to take your Alka-Seltzer tablets. I went ahead and broke one up so it's easier to put in the water bottle. So you're going to take your pieces and you're going to stick them in the bottom, and they're going to sink to the bottom, and they're going to react with the water, and it's going to cause fizzing, which is causing gas. So it's going to make those water bubbles at the bottom start to rise, because as the gas is produced, it's less dense than the oil, so it's going to move through the oil until the gas is released to the top, and the water is going to fall back down to the bottom. It's going to start the process all over again. So it's going to start mixing, and you can see it starting to have that lava lamp look. My food coloring isn't mixing super well, but it's starting to get there. The more it bubbles, the more it'll mix, and you'll be able to see it really well. So density is a big factor in why this works, but another reason that this works is because of the polarity of the two liquids inside. So water is a polar molecule, meaning it has positive and negative charges to it. So the hydrogens have positive charges and the oxygen has negative charges, so it causes things to be attracted to it because they want to take those charges, they want to use those charges. While oil is non-polar, meaning it holds no charge, so it's not attracted to water at all. And since you have a polar molecule and a non-polar molecule in the same space, they aren't attracted to each other, so they're not going to mix, which allows for the water to move through the oil without being mixed together, causing a new solution. So an at-home lava lamp. I'm going to do another tablet just to see if you can see it really good. Do big chunks. Okay, if you give it a second, yeah, starting to mix up really well. So you've got a more dense liquid at the bottom and a less dense liquid on the top, but the gas is causing the more dense liquid to move through the oil because of the air, or because of the gas. And then once the gas is released at the top, it just sinks back down to the bottom because it's more dense than the oil. And then it doesn't mix because you have polar and non-polar molecules working together. And that's how it works. Thanks.